Just 2 minutes. Sorry. It started. Hmm. Uh, okay. I'll send on the other group too. Uh, okay. So I'll just share my screen. Just 2 minutes. Okay. So we'll start with the easiest question and then we'll go above. And okay, so the easiest one with the most solved was K. So did everyone solve K? Okay, a few people didn't. Okay, so K, how are we supposed to solve K? In K, I'm given a few guns. I'm given few. I'll just zoom in a bit. Yeah. So I'm given few guns, and in the gun, I can load bullets as many as I want, and in one go, I can fire the whole gun. So I can fire the guns in any order, but I need to fire the bullets in such a order that they are strictly increasing. And what I am given is a permutation. So why is it a permutation that I am given? It's because I have n numbers and all of them are distinct. It is given in the question. Okay. So, how are we supposed to solve this thing? One thing that we can keep in mind, if we are finishing off one gun in the whole go, then the gun should have the last bullet that enters the gun should be the smallest one, and every bullet has to be greater by one than the previous bullet that was fired, right? So let's say I have a 2, I can have a 3, but I can't have a 5, because after 3 I will fire 5 and it won't be in an increasing order. So I can only have a 4, right? So we can literally maintain all these guns and just check for the next value that has to come, right? And just check for the next value that has to come. If let's say I have a 2 over in this gun, I am there are, let's say, multiple guns, but the next value for implementation, let's say the next value that I want is a 2, right? And if I get the 2 in the bullets order, I'll just place it here, and the next value I will want over here is a 1. So same way, so we can maintain a multi-set for these guns, uh, all denoting the next values, and we can go ahead. So that's it. So that's what I did. I maintained a multi-set of guns. If I find that X, then we remove that X and we insert X minus 1 always. And here we have the answer. So that was K. That's it. Now, coming to the second most solved problem, I would say. What was the second most solved problem? 352, 282 M. I haven't read M. So if anyone who has read and solved it would like to contribute, or nobody has doubts in M, so we can move forward. Hello. Hello, hello.
हेलो
हाँ हाँ.
या एज एन एम अपने को ओवरऑल दिया क्या है कि वी आर गिवन सम नंबर्स एंड वी नीड टू फाइंड आउट हाउ मेनी कैरी ओवर्स आर नीड टू बी डन
Okay.
एंड वन ऑब्जर्वेशन इज दैट no matter whatever order you keep, the number of carryovers will remain the same.
Exactly. Because your
So you
final
just need
answer
to,
remains the same, right?
yeah, so you just need to count number of carryovers while adding all the numbers.
Oh, that's it.
That's it.
Okay. Okay. So that's it. Okay. Again. So zero carryovers. Okay. So I have a 7 and I have a 77. So if 7, okay. So basically, if A plus, sorry, A mod 10 plus B mod 10 is greater than 10, then I'll have a carryover. Ah, understood. Okay. Ah, that's great. So is that one carryover or is that 7 carryovers?
No, we just have to count the number of carryovers. So you are adding 77 and 7, so
Oh,
it's 1.
77 and oh, so that's one. Okay. Oh,
Yeah,
oh, wow. So we just keep on reducing these numbers and oh,
yeah.
okay.
The just the number of carryovers.
Okay. Yeah, but that makes sense because whatever final output I get, this
Mm-hmm.
yes, that makes sense that the number of carryovers will always be same. Okay. Yes. Uh, Now continuing to the next most solved problem. Let's say problem E. Ah, that was shit problem. Uselessness. Okay. So what is problem E? If anyone wants a proof and stuff, I'll just give it. So what is problem E? Problem E, I have, I just forgot. Wow. This problem that gave me so much trouble. I forgot. Okay. So, understood. I'm given an N and I'm given a K. Okay. So, how do and I need to find a sort of a permutation such that the size K, this size K, is the parity of every subarray of size K in the permutation is the same. Okay. So, let's assume, so one thing we can say that we have a long permutation and we are sliding this window, correct? So what should happen is that, let's say I have some odd here, I have some even here, I have some even here, I have some odd here. Now my next element will be this block, right? But if I'm going to this block, I will have to remove this odd and I will have to get this odd here. So our pattern should repeat every k moves. That is one observation that we make, that every k moves we should have the same pattern. So if we can have this same pattern every k moves, then it's we are good to go. So if k is even, we can easily have a pattern of odd, even, odd, even. Because we are removing an odd here, we are adding, we have to add an odd here. If there is an even here, the parity changes. So if it is even, we can literally have it odd, even, odd, even, odd, even, and k will cover exactly n by 2, k by 2 odds and k by 2 evens in every subarray. So if k is even, the answer is always possible. Okay, great. Now, if k is greater than n by 2, still the answer is always possible. Why is it so? N by 2 floored. Okay. So the answer is still always possible. Now, why is that so? We can always. So, if you see, there are some elements in between that are useless. I can just do anything with it. So, if I have at least a few elements here, and I can easily have the same amount of elements there, I'll have n by 2 evens and n plus 1 by 2 odds. This is basically the seal. That's why. So this will be the number of evens and this will be the number of odds, right? So what I do is I'll have exactly equal number of evens and odds here. I'll have exactly equal number of evens and odds here. Now, my k is greater than n by 2, right? So I'll have a few spaces remaining because after this k, the remaining spaces, I'll have a few spaces remaining, n minus, namely 1, 2, something, but it won't be 0. Why? Because this part, will be n minus k, and k is always greater than n by 2. So the remaining spaces can just be, what do you say, utilized for something else. Like, sorry. So these are the remaining spaces, and in this remaining space, I can put two extra odds basically. Like, if you just compute it, let's take example of 51 and 103, right? So my k is not 51, but 51 and 100, right? So I'll have 49 here, and the 49 here have to be the exactly the same. So the last 49 has to be equal to the first 49. For this, we can have 24 odds, 24 evens. Same thing over here. So we'll have utilized 48 odds and 48 evens, and I'll have 50 odds, right? So I'll have 50 odds. 48 are utilized. I can have the same number here. So at least I am saying 2 will remain, is what I'm saying. At least 2 extra odds or 2 extra events will remain, and we can put 1 each. And we can have a 49 here, 49 here. And the remaining 2, we don't care because they are always covered. So this was one case of greater than n by 2. And then there is the final case of k less than n by 2. For that, what we can do? If we again observe, we are making exactly a few of these occurrences of size k, and then the last occurrences of meh, some sort of size. And in each occurrence of k, I'll have one extra odd value. Let's assume. So I'll have one extra odd value here, I'll have one extra odd value here, I'll have one extra odd value here. So I should have 3 less odd values so that everything is compensated, right? I should have 3 less odd values so that everything is compensated over here. So that's just what I'm checking. That if I have, let's say, so I'll have n by k floored blocks which I have to fill. Each block will contain k by 2 evens, k by 2 floored evens, and k by 2 sealed odds. And after that, we can have this thing going, right? So if we just have a look at the code, so this is k greater than n by 2 or this thing. So both cases are taken. Odd per block, odd even per odd even sorry, even per block. Then we have all blocks, so like the number of blocks, full blocks, and we have the remaining value and total odd. So whatever is the total odd remaining after putting all of these in the blocks should exactly match. And now the remaining should be total events plus total odds, because I will follow this block, the same thing I'm going to follow over here. So total events plus total odds, and my total even has to be less than even per block. Obviously I can't have two remaining total events. So we just have to check if this pattern of even and k by 2 events and k by 2 sealed uh, odds after followed by k by 2 sealed odds can fit in the whole permutation perfectly or not. So this is a construction that you get. And yeah, and how did we get to it is we wrote literally all kinds of test cases for this. So we did stress testing. If you see this test case, so this is small, but if you see this test case, 58 numbers, then we have uh, 58 and we have 61 and stuff like that. We did stress testing. That's what we did. So again, going ahead now, E was solved a lot. After that, what was the most solved question? A. Okay. After that, it was A. Great. Wait, I'm just getting a call. अपना contest रुको. Bye. हाँ. So A what proof, I don't know for a proof, but what we wrote was literally brute force. You are given a few heights, right? uh, let's say you don't have to take, you are given few building heights, you don't have to take m heights, and you can reduce or increase these heights, right? You can reduce it or increase it or divide it by 2. So increase by 1 or reduce by 1. Now, what is the minimum number of moves it takes to get to a certain height? So the minimum number of moves will be, let's say I have a height x and I want to reach height y. What is the minimum number of moves it takes me to reach x, to reach y from x? So one thing is, if y is greater than x, then I have no option left but adding. But if y is less than or equal to x, then I can start dividing. I just keep on dividing, and at every point, let's say like I have y upon x. Now then I have y divided by, sorry, not y upon x, but we have x upon 2, we have x upon 4, we have x upon 8, and so on and so forth. So every point I divide, I'll just find the, I'll just calculate how much difference is it from y, and then that part I'll add or subtract. I'll just do a plus minus over there. But why is that so? Why not do a plus first and then divide? So what the issue is, you can see it for yourself. If I do x and I'm going up by 2, then I'm going, let's say I'm doing a plus 4, then I'm having a plus 4, and that is also getting divided by 2. So after I add and then I divide, that addition has no effect or literally no effect. Same thing with my subtraction. If I subtract and then I divide, it has literally no effect. So I'll divide and then go till that point by adding and subtracting. So that is how I can get the minimum moves till what to divide. Now for the, now, okay, so I can, if I have a certain height, then I can get all the minimum moves, right? So for this, we can literally go through all the possible heights, right? So if I have a certain value x, if I have a certain value x, and I have x dash and I have x double dash and so on and so forth. So I'll have x by 2, x by 4, and so on till 1. This also till 1, this also till 1, right? So I just brute force on all these heights. Now my maximum value of this x or h, whatever you want to call it, is 1 in 9, right? Which is close to something like 2 raised to 30, 2 raised to 31, something 2 raised to 30 or 2 raised to 31, close to that. So now I'll have at most 31 different heights, right? And my, this is n square, and for every n, right? So I am having an n over here multiplied by, now for calculating move for an n to reach a certain height, I am again dividing by 2. The worst case will be 31 again into n for every move, and then my sort, right? And then it will be my sorting time complexity. So in how much time can I sort this thing? So like for getting the max m, we can just find the height of all of these m's and then sort all of them and then remove the last few m's. I just add the first few m's. So that is how you can do. And coming to why only these heights should be used, it is because, let's say I have this, my optimal height is something y, right? And now if I were to get to a y minus 1, and my y minus 1 is not in any of these, is not in any of these heights that I get. So so what will be the issue is that to reach a y minus 1, I'll take a lot, like this is the optimal route to reach a y, right? Because I'm just dividing by 2 and I'm keeping on dividing by 2. But now to reach y minus 1, I might have to increase something by 1 and stuff, correct? So we just take all the values that we get by dividing so that we can reach easily, is what I'm saying, and get the answer if you get it. Like, this was my intuition that if I have something called as y minus 1, and let's consider that it is optimal. So the minimum time to reach y is y plus some divisions, some amounts of divisions, plus some amounts of additions that I had to do, and uh, plus the amount of subtractions that I had to do. Additions basically stuff that is less than y reaching a y. So plus the subtractions, and this is the amounts of divisions that I had to do. So to reach y minus 1, I'd probably have to do similar amount of divisions or one more, or divisions, similar amount of divisions plus one more subtraction. And over here, the additions would be less and stuff like that. So like, I can't express it in words. I don't know how to, but this is what came in my mind as an intuition. Like, I proved that a y minus 1 won't work if a optimal thing y works and y is part of this. But yes, this gives you AC. Hello, understood? Hello.
Yes, yes, sir.
Oh wow. Magic. And coming to code, written by Janil. Boom boom. Oh, TLE
Seems that
test.
your
Nice.
screen is not visible.
Oh, my screen is not visible. Wow.
It is visible. I can see
Oh,
On
net issues.
YouTube.
On
on
YouTube.
YouTube.
What? No, I have
You
shared
didn't
my
share.
screen. No, I
Oh,
have shared.
yeah.
Net issues probably. But again, I hope I can submit a D. If I get AC, I will
दिखा
explain.
ले भाई कोड
Ah,
कोड तो दिखा दे
no, you explain better. I haven't written.
हाँ? अरे नहीं आई डोंट हैव आई एम ऑन
Wow.
फोन में लैपटॉप पे
Wow.
नहीं आई एक्सप्लेन लाइन बाय लाइन बाद में बट दिखा
So coming to, oh, sorry. Uh, huh. So coming to the code, I think
yeah
here is the number of moves that you can get. X
yeah
is less
to
than
reach
y.
y
This is
from a specific
used.
x
You keep on dividing by 2, and then minimum of answer. Exactly, yes. This you get. Then here he has kept the unique heights that we achieved. This is the small optimization that we made. Just a small optimization that we insert a
because
height.
if you directly do for every h by 2 you'll repeat a
Yes.
lot and that will give you TS.
Yes, because you can get a multiple same h by 2s. So why do for another one that can give TLEs? So exactly. And here is the answer, and he is calculating make. Make is basically for a certain x. I am making few values. So the whole A, he'll just go and he'll get the moves to reach there, and then we add that to the answer, we sort it and remove the last n values. So, and we return the answer, and we want the minimum of these. So that is how you can get AC over here. And why does this even work? This crazy time complexity into amount required for sorting, right? Which is n log n. So it is basically, yeah. So we are aiming to reduce this value.
No,
Yes.
no, it is just 31 into 31 into n square log n. Remove
Exactly.
one n cover. Remove one n cover.
Oh, sorry. F. My bad.
So,
My bad. 31 into n for calculating this. 31 into 31 into n square log n. You could say it is n log n the whole square.
no, no, n square log n, no?
So 31 into
N log n
31
log.
I am considering, or
Uh,
n square log cube n, I don't know.
no, but a log n is very small. Like
Okay,
log to
possible.
500, no, very small.
Yes. Oh, ha. Okay. So and this will be
Uh,
some 900 constant factor. 961
uh,
to be precise. 961 into n
n
squared
square log n.
log n. So this is the time complexity.
The
Worst.
value is 2e8, but your time limit in the question is given 6 seconds.
Yes,
So
so
it will be
it can run in that time. Exactly. So that is how you do this. And D, if anyone read, so it's literal brute force. You check for n into 2 raised to 13. You just pick and choose everything. You just pick and choose every question mark without a doubt. Right? N is 1000 and 2 raised to 13 comes out to be something should be some 8000 if I'm not wrong. Should be close to 8000.
yeah, yeah.
I don't know. So 1000 into 8000 is 8
But then how are you calculating the thing?
86. Recursion,
No,
basic recursion. So
that's all
I don't know
right,
if AC or not, but what
huh?
I'm doing is that in the recursions, and what you can do is that
So recursion का time
86 you
complexity
do
is
not.
different, no?
No, recursion is only 8000 time complexity. After recursion, my processing is happening
I
in
know,
O of
let's say
1.
if you're choosing whatever, let's say if I want to put it as an plus instead of minus, तो
हाँ.
वो x कौन सा x how do you calculate? So these after this x summation you get x.
Oh, I literally iterate over each and every one. So 2 raised to 13 different combinations, right?
अरे नहीं 2 raised to 13 is if I want to pick or not, right?
No, 2 raised to 13 you get with the combination.
No,
If
Okay.
you
actually,
write
he's
it
saying that.
recursively, but if you write it iteratively, like you probably might not get it. But if you write it recursively, then this means this I get it with the, like I am building the array as I am building a value in 2 raised to 13, as I am building 1010111. Let's say
हाँ.
these I have reached here. Now I have one. Now I have like a few more values. So if I have reached here, this array remains the same, so I do not need to construct this array again, right?
हाँ हाँ वो तो है.
Then
But what I'm
Yeah,
saying
but
is,
in
how
yeah,
do you calculate the
in
x?
x meaning,
X मतलब
oh,
you
how
have to
many
finally
ACs do I
बोलना
need to get and stuff
after
like.
how many
Oh, how am
submissions
I
you get
processing
penalty
each and
कैसे
every permutation you are
create कर रहा है.
asking?
हाँ penalty कैसे calculate कर रहा
Okay, okay. So
है
that
after
can be
choosing.
calculated in big O of one time. Okay. So while we move forward in this recursion,
Hmm.
then when we move forward, so what we keep track of is whatever ones we have taken. So let's say I have taken this
Hmm.
one, I have taken this one, I have taken this one. So there were a few WAs right before this one. We just add those WAs, right? If I've taken this one, and I will know exactly how many ones I need to take because I know the amount of questions I have solved, and I know the total questions I have solved. So I know exactly how many ones I need to take. So while I am taking these, so when my recursion ends, like I find all these 13, then uh, if I have a certain one, so first check is this: my ones don't have to be different. The second thing is every one can be manipulated. So I can submit from 240 till a 299, right, in my answer. So this is my varying range, correct? So if I am taking an A, so that means I have a certain total penalty. I have a certain total penalty now, and I have my given penalty. I have a given penalty. So my total penalty, I'll just add 240 times the number of t minus s. Why? Because these are the amount I have to select, right? I don't have any other option, but I have to select these. So this I am adding over here. That is one thing. And so then if I have added 240 already to my answer, then my range can be, I can add 0 to 59, right? Okay, anything from 0 to 59 can be added over here. This is one thing. Second thing is, okay, now when I go over here, I can, let's say I have taken all of these ones. So what is the maximum penalty that I can get? So there were a few WA submissions prior to this, right? Let's say this had 4 WA submissions prior to it, and then it submitted, let's say, just one submission, and then after the freeze, I submitted only 2 submissions. This had, let's say, 3 WAs. This had, you get the gist, right? So now all of these WAs should be counted, because why? I am considering all of these values as ACs. So I need to make this difference using this 0 to 59 and my penalties. If I'm taking this, so I'm subtracting few values from my difference, right? I'm subtracting the penalties multiplied by 20 from the difference, right? So that is one thing that I'm subtracting, penalties multiplied by 20. So I subtracted that value from the difference, and I am carrying forward maximum number of penalties that I can take. Now I have a value called difference. Okay, I have a value called as difference. So what is this value difference? This is basically what I want to make using the maximum penalties that I can use and the 0 to 59 that I can add. If I have to select, let's say 6, so I can add from 0 to 59 into 6. This is the time I can add. Why? Because my penalty is calculated 20 times WA, 20 times submissions, total submissions minus 1 plus my Y. So this is my plus Y, right? And I can do it 6 times. So I can add, subtract anything. Okay. Now the difference, I first utilize all of my penalties that I can utilize from this, and whatever is remaining I utilize it in the times. Now for India, and we just put it directly in the array. So this is what I'm doing here, that if my select is not equal to current dot size, basically this condition, if my t minus s is not exactly equal, if my ones are more or ones are less in this thing, so we return. If I am multiplying by 20, I'm using literally all of my 20s, and I'm using all of my numbers that I'm selecting is less than the difference, then also I return. Else if my difference is 0, I return. My difference can be 0. Why? Because when I'm selecting a 1 for being AC, it can be a so I am subtracting all the WAs from the difference, right? So this will work. It can go below 0. So if it's below 0, I return. Else it is 100% going to be true. So I am calculating how many 20s I need to use. It will be maximum the 20s I have available to use, and difference by 20, and how much time I will use. Time I will use is basically whatever is the remainder, which has to be between 0 and 90. It could be more also. It could be more also, but because if my 20s are only not enough, let's say I have a 40 difference. No, let's say a 60 difference is there, and I can just use one WA. So if I'm using just one WA, so I can get it to 40, right? Baki ka, it goes into the difference factoring. So that is that. The time I have to use. Now I am iterating over all the indices that I have selected in the permutation. And each index unsolved question denotes the index in the original array, solves before freeze, and these are the solves after freeze. So that is what an unsolved question denotes. So now I get the index and I'm solving it, right? So I put it as a plus sign, and then I have actual 20, how many I'm using over here, right? So it will be at most how many I have solved after freeze, and the minimum of the 20 I am using, right? Submissions after freeze. Oh, this should be submissions after freeze minus 1. Yes, another W. Wow. But again, this is the submissions I made after freeze. Now I subtract it and then I update, like the before freeze, the actual 20s that I used, and plus 1 because I got an AC submission also. Same thing for the time. I'll just subtract from the time itself, and so on and so forth. So this is how we just keep on going. And in the recursion, we just push back. And for the 20, we have unsolved after the freeze. So after freeze, how much ever I am solving, minus 1. Because one of the things that I will be solving after freeze is without a doubt is without a doubt going to be an AC submission if I'm taking it as an AC. And the next index unsolved, and basically the difference minus unsolved before freeze into 20, taking into account the WAs. This one, we remove it, and then I'm doing a valid match is true. If it is true, then we just break, and yeah. So same thing, we remove it and then we recurse without it. We didn't select it, and we go up. And while printing, you can just handle this, is just implementation, useless. So this is how I am calculating it. And yeah, so this should be minus 1 probably, yes, after freeze minus 1, because I can't use all of them, right? Yeah, these are the submissions after freeze, right? Unsolved question current, and I'm pushing it back as it is. Yes, so this should be minus 1. Yes, so this works. 343. Yes, exactly. This works. So I got an 89 240, and works well. So let's just submit if I can, or I still can't. Oh, okay. I hope I can submit it. I don't know why I won't, but this is how you solve D. Very implementation heavy, and you need, if this is a very implementation heavy
Sir,
problem.
DOM ka code, no?
Oh, DOM ka code. Oh, mind as well. But again, it's a very implementation heavy problem. And if you are solving any implementation heavy problem, then your variable names need to be nice. They can't be bad. Oh, I can't see because I haven't solved the problem yet.
Oh, yeah.
So one thing keep in mind, if the problem is very implementation heavy, make sure that the variables are well named. Because in your team, if you are like, let's switch now, so if you switch and he's like, what is 0, what is 1, and this and that, but if he reads what is before freeze, what is index, then it's just easier to understand. So just write it a bit cleanly, because you also might get lost, right? While doing this, you have a few steps, and then while doing this, you also might get lost. So that is why I should have taken variables of penalty time and extra time and stuff also. Should have been better. But yeah, the same thing with min time also. For one, we can give actually at most 59 LL, and yeah, so that is how you get an answer. And I hope they freeze. Keval Jain, please unfreeze the contest. I want to submit D. Or it might have been unfrozen by now, but nobody submitted. I don't know. But oh wow, we would have come quite high if D solved. Shit. Sad.
Exactly. That's why I was like, D पे focus करो. See भूल गया तो.
Shit. पर और
अरे
अपना
we
मिस
took
भी
a lot
कुछ
of time in E.
भाई
ना,
अपना
that's
मिस
why.
भी 1 मिनट से ही हुआ रहेगा, ज्यादा सेकंड से मिस हुआ रहेगा सबमिट करना.
हाँ भाई. नहीं. 2-3 बार अपडेट था. और रहने देगा, नहीं होने वाला था.
हाँ, एक अपडेट
But
हुआ
the
ना
thing
अपना,
is,
2-3 और अपडेट नहीं, ये वाला
अरे
अपडेट था.
तूने अभी जस्ट अपडेट किया.
हाँ वही, वो एक अपडेट, वो नहीं. अरे पर डब्ल्यू आता तो समझ तो जाता थोड़ा, इज व्हाट
हाँ,
आई एम
प्लस
सेइंग.
ये जो डिफरेंस वाला था.
हाँ, ये तो
That
कब
we
का
did
करा
like
है.
2-3 minutes after the contest.
नहीं, दैट वाज ड्यूरिंग द कॉन्टेस्ट. आई सबमिटेड दिस तो ड्यूरिंग द कॉन्टेस्ट.
नहीं.
इंटू 20 सबमिट नहीं किया था, ये वाला सबमिट करा है ड्यूरिंग कॉन्टेस्ट.
हाँ, तो 20,000.
हाँ, इंटू 20 नहीं किया था.
ना भाई.
हाँ, वो डब्ल्यू था, बट इंटू 20 करना है, इज द थिंग.
हाँ.
तो हाँ, तो आई वुड सजेस्ट एवरीवन टू राइट क्लीन कोड.
अपने को ई में बहुत टाइम लगा. ई का क्या था वो? I didn't understand it. अरे
E basically
Error
your
क्या होता है?
odd items per block is k by 2 seal. Even items per block is k by 2 floor. And
Yeah.
you just need to check if every block can follow the pattern, even all evens, then all odds. So basically, if it can follow k by 2 evens and k by 2 seal odds,
Yeah.
and for that, for the final block, that is half, it should follow still the same pattern. So can it follow that pattern? You just need to
हाँ,
check.
मतलब वही करना.
हाँ,
I did that.
you did that.
Error क्या था तेरा?
हाँ,
Error क्या था W?
एरर. अरे एरर ये फाइनल इफ कंडीशन में था. फाइनल इफ कंडीशन में ये वाला लेना था, टोटल इवन लेस देन इक्वल टू इवन पर ब्लॉक. दैट वाज द इशू. बाकी एवरीथिंग वाज करेक्ट सिंस अ लॉन्ग टाइम.
Yeah.
हमने अरे यार ये क्या बकवास है. बट हाँ,
E जल्दी हो जाता then D was 100%.
D was, in my opinion, if I get an AC then it was easy. If I get a WA then it was hard. Because
नहीं यार, approach seems right. There is
yes,
no...
it seems very right.
Yeah.
It's literal brute force, right? So n into 2 raised to 13.
देखना पड़ेगा. C will have to solve.
So literal brute force. And I also have optimized it a bit because I am not iterating over all questions.
Yeah.
I'm iterating over the unsolved ones only. But worst case, obviously, 2 raised to 13. Should work. But time limit is just 2 seconds. So worried. I don't know.
1.5.
There has to be
Oh,
small
1.5
optimization because you
Why?
have to select exactly M. So if you can generate those M easily, then no big
But
deal.
why do you need optimization?
If it TL is.
Why?
Because if you have to select 13 and there's 13 questions, so there's just one answer, right? And if you have...
But what I'm saying is 2 raised to 13 into 1000 is 86, which is more than enough.
86, I know that. And then there will be some overheads of struct and long XYZ.
That overhead, if you give it 10 also, that will also be fun.
Should work. 87. Fair enough.
This one too.
But okay.
Keyur, sir, how do you solve
E.
B like F? Which ones? M and all. very
Keyur
fast.
by Giga Chat. Boom.
Actually, Pratik and Samir also did well. I guess E was done by Samir and Viraj. Sorry,
Okay.
Samir and
Did you
Viraj
solve it?
actually, we all solved all of them together, but E was solved by Samir and Viraj. They did it damn quick.
Oh,
Quick.
They were missing it in very small test case. Like if n equals 1 and k equals 1, so you should be printing yes, but they were printing no. That was the only mistake they did.
Oh.
damn.
Oh. Oh. Damn. Yeesh.
They
What?
figured it out damn quick.
Yes. Same with K.
K also you figured out. K you figured out very fast.
Yes.
M to was once you see that carry doesn't changes, then M was easy.
Yeah.
Yes. Nishant
Okay,
is
to
like,
see
he
that.
wakes up from sleep. He reads M. He's like, carry doesn't change. Oh, okay. Carry doesn't
Then I code
change.
fast.
Okay. Wow. Nice. AC. Like, carry doesn't change. Yes, AC.
AMA, where were you stuck at?
In A, we were not able to figure out that. You said now that we'll keep dividing by 2, and one of them would be the most optimal height. We couldn't figure out that.
Oh, dividing by
Oh.
2. The optimal number of moves to reach a certain height.
Yeah, we couldn't figure out that. It would be, just the floor value of division by 2 of
Understood.
any of the given.
Because adding before or subtracting before doesn't make sense at all. Because what you are adding is just and after that, if you are dividing, it doesn't make sense, right?
Yeah.
So same thing. Oh wow. Oh, IET Lucknow was setting this or what? Oh, he's giving a virtual. Okay.
No, but Mridulai said this.
Oh, Satyam also might be possible. Who knows? Mridul also.
I know it in the contest.
Setters. Oh, okay.
Setter is Mridulai.
Oh, set. Okay, he compiled. Oh, fair enough. Wavis. Oh, wait. If I give virtual and just submit D. Yes! Magic! Yes. We'll sign in via alt. Or a team join. Sad. Damn.
But just give it na virtual. Kya farak?
This guy giving virtual only.
Virtual without teams also.
Yes. I'll do
So
after
in
lunch.
D, you are selecting some, let's say, some number of question marks, and then in the end, you are keeping a track of, let's say, I've selected some number of question marks.
How much?
We are keeping of the minimum penalty will be having if we are selecting these options.
Exactly. And if I have left this penalty, so I'll have the minimum penalty. Let's say I am having, and after that also, if minimum penalty is less than the total penalty that is given, if it is given and the calculator is less, so if I can increase or not.
Okay.
That also.
Okay, so first we'll try to increase it by 20 and then by the remaining.
Exactly.
Okay,
Basically, we pile on 20 and then fine tune it using these remaining ones.
Okay.
Exactly. So that was it. Yes.
It was pretty straightforward, but implementation heavy.
Very implementation heavy. It took me around an hour to write this much. And implementation heavy, so then you can get issues. Just like I found this one. This was an issue. It's giving an AC in these two answers. But here, it might be an issue going ahead. So this was an issue I found now while explaining the code to you. Rest all I think should be fine. But yes, very implementation heavy question. And if you don't have your variable names right, sir, it's just gone. It's just ones and zeros everywhere in purple. UK of 0 minus 1, UK of 1 minus 1, and stuff like that. It's just better to have a struct. I don't know why, but yes, it's
Fair.
peace of
Yeah.
mind. Like I can
Today's
understand.
contest is 9 p.m. by the way, not 8.
9 p.m. Yes, let's go. Today's CF. Ha. Any more doubts? So I can lunch. I know
Yes,
not
yes.
that good at
Almost.
explains, but again, any
End
more
stream,
questions
sir.
you read or want to share was interesting,
End stream.
or we should try.
H करना है. H is
H,
doable.
wow,
I see.
Majik.
I read
Damn.
H once, but I wasn't able to understand the question itself. Like there was just 4 or 5 ranges given, and the output was 800 something.
Yeah. So the thing is, wait, H खोल.
But this is, if you can say, I think they have set this contest on their own. It can't be like, at least some problems are on their own. It can't be that
Yeah.
this
Probably.
contest is completely from gyms, because this is a deep problem. I don't think anyone else can even think of this, and I'm very sure that this will have some sort of significance. Wait, let me just pull up IIT Delhi triple. Oh no, 7 solved. They solved 3 or 4 probably. But is this Amrita regional DOMS performance? Could be. But yeah, this might have some significance. Who knows? Before freeze,
Yeah.
this was DOMS perf. Wait, let's just see now. Amrita Puri ICPC regional 2023. Huh. If it is, then very well thought out. Like you could have put in someone's. Okay, B, C, E, F, H, J, and L. Oh, this is 10, 11. Oh, only 12 problems or what? Okay. But okay, you are. This could have been probably someone's perf at ICPC. If it is, then wowies. I'm just wow. So nice. Yeah. Okay. So, anyways, move on. Hello.
Hello.
Next question. Just move on.
Go to H now.
Edge.
I'll explain the test. Yeah. So basically, we don't care about how you merge it, but at the end, जो भी बाकी रहेगा, that will merge, right? The last 2 segments you will merge anyhow.
Yeah.
Yeah. So if you have, let's say, 2 different segments, 1 to 10 and 10 to 20 to 30. So you have basically 10 into 10 combinations, right?
Okay.
Of all the possible XYs.
Yeah.
Yeah. So
So
similarly,
will
in
we
the
insert